Let's take a look at the homework for lesson 3.1.4. There can be more than one answer for each of these. Which of the following satisfies honk 1, 2, 3, 4? Remember that means that hydrogens can form one bond, carbons can form 4, oxygens form 2, nitrogens form 3. So let's start with carbon. Carbon is in group 4A, so it has 4 valence electrons. That means that it wants to make 4 bonds. So 4 hydrogens, each with 1 valence electron, could end up making CH4. This would also satisfy the octet rule because now the carbon is surrounded by 8 valence electrons. So that would be a stable compound that we could find. For the nitrogen, nitrogen's in group 5A. That means it has 5 valence electrons. So it has 3 lonely electrons. Oops, I meant to make that a different color, but that's okay. So you can see NH4 would not work out because there's already this lone pair there. And this makes nitrogen very happy because now it has the great 8. The other ones would not work out. Next, it wants us to draw some Lewis structures for these other compounds. Let's start with HBr. Hydrogen has 1 valence electron. Bromine has 7. 1, 2, 3, 4, 5, 6, 7. Everybody's happy there. Bromine's got the great 8. Hydrogen's always happy with just 2. Silicon is in group 4A. So 1, 2, 3, 4. Chlorine is in group 7A. So 1, 2, 3, 4, 5, 6, 7. And we'll do another chlorine on the bottom. 1, 2, 3, 4, 5, 6, 7. Keep going around till everyone's paired up. And then there's 2 hydrogens that we can put at these other spots that need another electron. Sb is in group 5A, so 1, 2, 3, 4, 5, and it is with 3 hydrogens. 1, 2, 3. Se is in group 6A, 1, 2, 3, 4, 5, 6, and there's 2 hydrogens. And Ge has 1, 2, 3, 4 valence electrons, and so each hydrogen will go right next to those extra electrons there. Which molecules have the same total number of electrons? Well, hydrogen's got 1, bromine has 35 total, that makes 36. Silicon has 14, each chlorine has 35, and there's 2 hydrogens, which each have 1 electron, so that makes 86. Sb is 51, plus the 3 hydrogens makes 54. Selenium's number 34, plus the 2 hydrogens makes 36. Ge is number 32, plus the 4 hydrogens also makes 36. So SiCl2H2, H2Se, and GeH4 all have 36 total electrons. Which molecules have the same number of valence electrons? Well, hydrogen's got 1, bromine's got 7, so that makes 8. Chlorine's got 7 valence electrons, and there's 2 of them. Silicon's got 4, and each hydrogen has 1, so that's 2. That makes 20 valence electrons. Sb has 5, and each hydrogen has 1. That's a 3 total. That makes 8 valence electrons. Selenium has 6 valence electrons, and there's 2 hydrogens, each giving 1 valence electron. Ge has 4, and then there are 4 hydrogens, each giving 1 valence electron. So which molecules have the same number of valence electrons? All but the SiCl2H2. What patterns do you notice in the number of H atoms? Well, the number of lonely electrons seems to equal the number of H atoms with all of the examples except one. Like if we go back, bromine had one lonely electron, so it has one hydrogen. Sb had 3 lonely electrons, so it gets 3 hydrogens. Selenium had 2 lonely electrons, and Ge had 4 lonely electrons. Then it wants us to draw some structures. So the way that I like to tell people to draw these is first draw the dots. So since fluorine is in group 7A, each of these gets 7 valence electrons. And then connect the dots. Te has 6 valence electrons. I'm going to point the lonely electrons at each other on purpose so then I can connect them to create the structural formula. Oxygen with its 6 valence electrons. Chlorine has 7. So I'm going to point the lonely one up, and then I'm going to connect those. Carbon has 4 lonely electrons. Each chlorine has only 1 lonely electron, which I'll point at the carbon so that they're easy to connect. And each hydrogen has 1. One trend you'll notice is the first atom is often in the middle unless it's an H. Last question, which of these satisfies honk 1, 2, 3, 4? Well, NH3 is the only one that does because nitrogen has a lone pair, and nitrogens can only make 3 bonds. So the answer would be NH3 for all of these. Oops, NH3.